So if a formulation targets a particular area of the skin, why don't we measure levels of drug in the skin itself? Why do we do permeation across the skin, or IVPT?
So I can speak briefly to that. When we think about, let's say, antipsychotic compounds, they may act in the brain, but when we evaluate rate and extent, and we're comparing that between a test and the reference product, we use plasma PK studies as a surrogate for that. And so I think the idea here is to evaluate, at or near the site of action. I think the intention is to look at the high resolution cutaneous pharmacokinetics rather than just looking in the skin. And there's a couple of reasons for that. You could look in the skin, but for many compounds, it's not as simple as having a single site of action. In fact, we used to be, and I think in the past, more certain about where the site of action was for topical drugs. I think we now understand that it's more complex than that. Also, just mechanistically, kind of technically, in order to do an IVPT study where you can look at the concentration over time in the skin, you would have to set up that number of diffusion cells, that number of donors, and that number of replicates at every single time point, and then destroy them at every time point to get that sample of skin. And then extracting that and the validation techniques and approaches that are required are incredibly complex. So these are very, very, very intensive and very, very expensive studies. And you'll see some data presented later in the workshop. Most of these studies that have been done are the intellectual property is owned by the pharma companies that haven't really been published. And what you essentially see is a phase lag that as the cutaneous pharmacokinetics in the epidermis continue to permeate down into the dermis and then continue to permeate down into the receptor solution, you essentially see just a small phase lag. And so the information you're getting in the receptor solution is very high quality information and very efficient. And it tells you a lot about what's just permeated through the preceding layer of skin.
If I could add to that, Sam, in my talk, I mentioned, of course, that microdialysis is a technique that can be used also, but microdialysis is a much more cumbersome technique, and you've got the issue of pore size in the probes itself. Whereas when you're looking at topical products, I mean, the driving force, the flux across the skin, we're looking for the differences there. And that we believe, I'm a big believer in, is really the key element for topical absorption, is that without of course the depot formation and those kinds of issues in the skin, but is really that flex issue, getting an understanding and getting a handle on that is what is the key or the most important issue there. Certainly there are other methodologies, but then you've got to start balancing the availability of it, the cumbersomeness of it, the cost of it, and the flexibility of the methodology. And right now, I think microdialysis, I really do like it as a methodology or a research tool, but it has a lot of limitations that you don't see in IVPT.
Also, typically, we are using dermatome skin. Full thickness skin can be, for example, 2 to 3 millimeter. So what you are seeing in the receptor represents what is coming across the skin, but also to some extent what is coming in the dermis.